Hi. So in this video, we'll see about finding f of z if v is given by using Milne Thomson method. So given v equal to e power minus 2xy sine of x square minus y square. Now let us differentiate v with respect to x. So vx is e power minus 2xy into sine differentiation is cos of x square minus y square into 2x plus sine of x square minus y square into e power minus 2xy into differentiation of minus 2xy is minus 2y. Also, we'll find Vy. Vy is e power minus 2xy into sine differentiation is cos of x square minus y square into minus 2y, because minus y square is minus 2y, plus sine of x square minus y square into e power minus 2xy into differentiation of minus 2xy is minus 2x with respect to y. So you have Vx at the point x equal to z, y equal to 0. Let us find that e power 0 into cos of z square minus 0 into 2z plus sine of z square minus 0 into e power 0 into 0, because y is 0. So this will give you 2z cos z square plus 0, which is 2z cos z square. Since e power 0 is 1, you get this answer. Let us find Vy at the point x equal to z, y equal to 0. This will be e power 0 into cos z square minus 0 into 0, because y is 0, plus sine of z square minus 0 into e power 0 into minus 2z, which is minus 2z sine z square, because e power 0 is 1. Right. Now we have found these points Vx and Vy at the point x equal to z and y equal to 0. Now we can just go with CR equations. So what are CR equations? Ux equal to Vy and Uy equal to minus Vx, right? So what we could do, we could replace Vy as Ux. So this equation is satisfied because f of z is analytic. Okay. So now we will replace Vy as Ux. So we can just find f dash of z is Ux plus Ivx, as we know. Substitute Ux is minus 2z sine z square, because that is your Ux, which is going to be Vy, plus I into 2z cos z square is Vx. Okay. Now we will integrate on both the sides with respect to z. So I'm just putting the integral sign on both these functions. Right. Now when you integrate f dash of z is f of z, and you can just take integral separately, minus integral 2z sine z square dz plus I into integral 2z cos z square dz plus c. Now you put z square equal to t, which implies 2z dz equal to dt. So that will become f of z equal to integral minus integral sine t dt plus I into integral cos t dt, because 2z dz is dt and z square is t. Now integration of sine t is minus cos t plus I into integration of cos t is sine t plus c. So which will be cos t plus I into sine t plus c, which is cos t is nothing but z square. So z square plus I sine z square plus c. Cos z square plus I sine z square is e power I z square plus c. So this is your function of z, f of z. Now f of z is found, e power I z square plus c. Now we can also find u given v. Suppose if you want to find u, then we can make use of this f of z and get the answers for u as well as v. Okay, right. So e power I z is x plus I y, as we know. So x plus I y whole square plus c. Now you can just find x plus I y whole square is a square plus b square plus 2ab, that is x square minus y square plus I into 2xy. So you can just multiply this I inside, I into x square minus y square, I into I becomes I square, which is minus, so minus 2xy plus c. So e power I into x square minus y square to e power minus 2xy plus c. So you can take e power minus 2xy into e power I of x square minus y square is cos x square minus y square plus I into sine x square minus y square plus c. So now you can just multiply e power minus 2xy with cos and with sine plus I into e power minus 2xy sine x square minus y square plus c. And this side f of z is nothing but u plus iv. So we can equate real and imaginary parts. U will be e power minus 2xy into cos x square minus y square, and v is e power minus 2xy into sine x square minus y square. So